Hello and welcome to a tutorial where we're going to show you how to link a Simulink diagram to a Matlab script. So I have a Simulink diagram here, and its purpose is to help run the Whomping Willow project, in which we're sweeping a beam 180 degrees as fast as possible. So you see I have a different block set up, and I have some values baked in representing some inertias, some gearboxes, some motor constants. And when I run the file, I'm able to simulate that and see some values out on the scope. So here I have the theta plotted and my RPMs. So that's fantastic. However, it is a bit manual. Like, I've got to bring these cursors around when I want to measure anything myself, and it takes a good while. In LT Spice, we started figuring out how to use measure commands, and we'd like to basically enable you guys to do the same sort of thing to speed up your work in Simulink. So an easy low-hanging fruit is like these gearboxes and different values here. Like, these are the same thing. If I'd like to change it, it's a little unfortunate I have to do it in two spots. So would it be possible for us to just use a variable? Well, if you go ahead and you name it, you'll notice that it flashes red and it gets mad at you that it's not defined. And that makes sense. We haven't done anything to define it. But it's actually quite easy. You see, these are just going to fetch from your Matlab workspace. So if we go to your Matlab and type in your command window, you can actually define a variable in here. And GB just appeared over here, and then we head back to Willow, and then when we run it, you notice it ran just fine, and my scope is going to have that same data as before. So that's fantastic. So now we can start to update and manipulate our plots. So we could start putting these variables into Matlab. So I might want my KE in here. I might want my KT in here. And excellent. And so then I can start defining those names over here in this workspace. So I can go ahead, KE, and you'll see that value appears right here telling you that it's a defined variable. And I put my KT in. Excellent. I run that, and it still goes without problem. But this is a little tedious having to type stuff in here every time. And what if I want to like close Matlab out? It would lose my workspace, and I would like to be able to save that. So that's where scripts start to come in. So what we can do is we can write a new script, and we can start to instantiate those variables. So I'm going to say define constants right here, and we can start adding those. So I'm going to put KE equals 0.0655, KT equals KE even. We'll use semicolons to end this. J equals 7, gearbox equals 100, and start to add in some, well, I like to put these at the top for clear, CLC, and close all. And we're going to need to name this file, so I'll call it Willow Script. It can't be named exactly the same thing as your Simulink file, otherwise it'll throw you some error about name shadowing, but that's perfect. And now when we run these, we'll see that they show up in our workspace. Now you may be wondering about line 1. This is just a very useful consistency line, because if you come down here and you were to define other variables, like if we defined a stop time and we have that equal to 1, then that shows up there. And then if we came back to our Simulink and we started using that, like maybe stop time is what we want right here, then that's going to work. However, when we come back to our Matlab, and then if somebody else ever, we'll still be able to run that simulation because stop time is defined, but if somebody ever comes through and clears it, and then we run the file again, we don't have stop time anymore, which is really good. Like, if we didn't have this clear line in here, then that value would actually stay. So if I like to find an H of 5 and then we ran it, that H is going to hang around. So it means you could get it working on your own computer, but when you go to submit it and when the professor runs the script, the variable was never defined in the script. So this line is great. Clear will make sure that the workspace is fresh. CLC is going to clear out any nonsense in this terminal, and close all is going to make sure your plots open fresh every time. So I'm going to go ahead and add all those variables in my Simulink and this file, and I'll meet you back here. Hey, welcome back. I've gone ahead and I've added those new parameters to my simulation file. So if we look back in the Simulink, you'll see I've started to use L and R and different variables for like the break time and the start time and my inertia, and they're defined up in this file in Matlab. So now when we run that script, all of that's defined and we can run the simulation. So to demonstrate its use, I'm going to try to get both of those on the screen at the time. So I'm going to open up my scope and pull this over to the side. I can keep everything going at the same. So now everything should be connected together. So I'm able to change some values over here. So let's say I think this isn't updated, so I'm going to run this. And then I can press run over here. And we'll see my plots are updating. Fantastic. So now we have a live link between all those. However, there is still like, I've got to press that run button, then I got to press that run button, and then I've got to use these cursors to see what I'm interested in. So we're interested in trying to reduce the total number of clicks. So there's actually a great little command for that we can use, and that is the simulate. So we can do sim and then type the name of the .slx file and tell it for how long we're going to simulate. 10 seconds is great. And normally you'll put that to an output variable called out is very common. And now I can just press, we can update here. It looks like we brake really hard, we go negative on our speed, so I want to do a little bit less of that. So now when I run this, great, you see I just pressed run and then the whole simulation ran. So that's fantastic. We've already gotten this guy out of loop. We no longer need to press run. So okay, and what's coming out of this simulation now? We can try to plot out, and if you try that and you run it, you're going to get an error because there's really not any data being ported to this out variable. You'll see nothing will show up in this window here. But what we can do is we can use a special block in here to port the data out. So just like your scope that we're using, we can use a block called toWorkspace. Now with the toWorkspace block, we can send anything we want to the output. Now it's a bit more limited, so we have to do a couple tricks to get everything we want. I'd love to see my RPM and my angle degree. And so to do, we can take one of those, pull it on in. Great. And now if I come back here and I run this simulation, you see just pressing this button, it'll run. Everything's happy, and then I get this cool simulation data inspector that shows me all those variables. Now if I'd like to put more, it's actually not too bad. I can just go back into the Simulink file, and I'm going to use something called a mux. This lets you pipe multiple things into the same simulation out block. So we're going to include our angle and our RPM and pipe both of those into there. Now when I head back into Matlab, when we run that, it's going to take its sweet time, and you'll see we have both graphs. And we can even start to get them in like the normal Simulink plot style. If you do .sim_out, we'll get both plots on a normal Matlab file. So excellent. Now we have like the whole loop is closed. We don't even need this scope anymore. We can close that. We can do everything we want to right here. So, however, there were some nice things about that scope that let us like look at the final values of things. Because if I click here, I still need to come up here and like look at where my angle ends up around 146. But now that all the data is in here, we can actually start to work on it and use all the code skills we've learned. So we can start pulling variables out. So first thing you usually do is pull out your time variable, and then we can start pulling out the different data variables. So those are going to be stashed in the .data object, and they're going to be column vectors, and you're going to need to get the ones you're interested in. So this is going to be defined on the order you put things in the mux. However, you can usually find it pretty easily. Like if we go look at the .data member, you can see these are the angles and this is the speed over here. So we're going to want the first column for the angle and the second column for our RPM.